Good evening, everyone. Thanks for being here. This is AI for Developers, LinkedIn virtual audience. Thank you very much. Thanks for being here. We got a great lineup for you tonight. We're also having a conference on January 29th, 30th, and 31st. So if you'd like to register, we closed GA registration for the meetup on December 8th, but we're opening it back up for one night. So if you haven't registered, scan this QR code, and you can skip the line for a GA pass. We're going to have speakers from Hugging Face, GitHub, IBM, Canva, Second, Anyscale, DeepMind, Meta, and so on. So it should be a good lineup. Check it out and register. The dates are up in the upper left-hand corner of this slide. That's January 29, 30, and 31. So that's the conference, everybody. And this is the conference location. This is called the Hibernia. This is approximately 5 blocks from here down Market Street. It's an old bank from 1892. It's a stunning 4-story building, stained glass window, as you can see. The basement's full of these excellent rooms that used to have gold bullion bars in there. There's no more gold there. I looked, but it's a good spot for workshops and things like this. And so we will have workshops and presentations so you can learn about new AI-powered tools and workflows and be trained on them in the workshops. So that's the itinerary for the conference. Check out the website for more details. That's at the conference. Tonight, this is our final meetup of the year. We've got a great lineup. First, we'll hear from Sidney, then we'll hear from Dave, then we'll hear from Hakan at 8 o'clock. If you'd like, you can come up here to kick off networking. We do an open mic for about 5 minutes, 30 seconds, 60-second announcements right here. So if you'd like to introduce yourself to the community, you can. And then we'll have some pizza and some cake as well, because it's the holidays. It's optional, don't worry. Okay, doors close at 8:50. And without further delay, I'd like to introduce our first speaker. This is Sidney Rabsatt. He's the head of product at Anyscale. The title of his talk is Bringing RAG-Based LLM App Ideas to Life with Anyscale. So without further delay, let's hear from Sidney.
All right. Well, thank you, Jackson. Yeah, you'll notice really first off the bat that the title of this talk is different than what Jackson just said, so apologies to Jackson. Just real quick question. I just have 2 quick show of hands questions. How many people in here consider themselves machine learning experts? And I'm not saying that in an egotistical way, just, are you ML experts in the audience? How many people out there have actually deployed a LLM app in production? Okay, pretty cool. All right, well look, I ask because that's going to kind of determine how far down the rabbit hole we go here. I'm a product person, so I can't go nearly as far down the rabbit hole as some of my awesome colleagues that I work with in engineering, but they do involve me quite a bit, and so I'm very happy to be with you guys today. And I want to talk a little bit about some of the great work that the organization has done over time, just to orient folks briefly. Anyscale, we're an AI app platform. We were founded in 2019, came out of a really cool project that was started at UC Berkeley by the PhD program. And they solved a really interesting problem that had to do with, delivering machine learning at scale across distributed compute environments. And, fast forward to 2023, and that software is used in some of the most interesting, most complex, largest AI systems in the world. A lot of the technologies you know and love leverage Ray under the covers to both train as well as to serve and deliver batch inference for a lot of the machine learning models that are out there that people use every day. Uber, DoorDash, Instacart, OpenAI, et cetera. And so, we've been really fortunate to be able to work with folks like this to help them bring AI to market. And I want to talk a little bit about some of the things that have happened recently, because I was originally going to make this more of a RAG talk, but what we're really going to do today is talk about some of the things that have happened over the last 2 weeks, actually. We had a lot of releases happen. So let me get into it a little bit. So on the Anyscale side of things, we've been focusing specifically on LLMs for a little while now, and we've been making really fast progress. I want to share with you a little bit about our journey. It started off with just trying to figure out, how do we help people make good decisions around which LLMs to use for their applications. We saw that, there were a lot of proprietary success from folks like OpenAI and others, But we also saw that there was an opportunity to have open source models, have something to say. No pun intended, I guess. And so we created a technology, we called it Aviary, and it was all about, how can we run multiple models, help people understand how well they could perform, quality-wise, and give them the ability to bake it off and figure out what LLM was most applicable for their application. One of the things that happened as we did that is we realized not only were we a good technology for building a website like that, but we also built technology that was also really good at managing multiple LLMs and running multiple LLMs at the same time. And so we took that and put it into a product. That's what we call Anyscale endpoints. And it's basically OpenAI for open models. We made the Llama 2 family of models available, as well as fine tuning. So we had serving and fine tuning for, folks to be able to hit an API endpoint very, very quickly and easily. You'll see a little bit later what that allows you to do. The next thing we did was say, look, it's great that we can make this available publicly, but a lot of organizations might want to be able to turn LLMs loose on their private data, things that they don't want to go outside of their walls, or just want to have more control end-to-end over that data flow. And so we made private endpoints available that does all the same things and more that endpoints does, because now we want to give you more control over those models. And as I said, the platform is capable of doing much more when it comes to fine-tuning, training of your own foundation models, even if you want to. And so we made the private endpoint solution available, added more models, keep fast-forwarding, adding more and more models. But over the last couple of weeks, things have really kicked into high gear when it comes to not only models, but some of the capabilities that we're releasing alongside. And so what I'm going to talk about today is some of the new things that we have available, show you guys a little bit about what those enable folks to do. And yeah, that's what I plan to talk about. All right, let's jump into it. All right, so one of the first things we did, not one of the first things we did, one of the first things I'll talk about is an integration that we built with Portkey. Portkey is essentially a front door to your LLM world, and it gives you, kind of an operational interface to wrap around your LLM application. So it gives you observability. It allows you to track how your LLMs are being used across various providers. And we're seeing more and more that folks are leveraging not just one model within their application. We're seeing folks oftentimes leverage multiple models within applications. They may have multiple general purpose models, whether it's a proprietary one and a combination of open source ones that they make decisions about how to shift the traffic back and forth between. And then you'll also sometimes find task-specific models sitting behind executing specific things. And so, solutions like this just, give you just more optionality, the ability to get reliability, load balancing, all that kind of stuff through your LLM application, and just gives you more options as you look to deploy something like that. This was the one that, that I think is kind of cool, because I've been messing with it and trying to make it say all kinds of rude things. I call it the chaperone, but, as you guys may have heard, Meta released Llama Guard last week. I think it was last week. The time is moving so quick. It was last week, last Thursday. And this one was all about making sure that we had an answer for content moderation. So if you recall, there was an AI alliance, organization that was announced earlier that week. Later that week, there was the Llama Guard model that got released. It's based on Llama 2.7b, and it just basically gives you a result that's either safe or unsafe, and if unsafe, why. I'll show you a little bit about what that looks like if you haven't seen this. Not only are there default classifications, there's I think 6, maybe 7 default classifications that categorize things like violence and hate and all kinds of stuff, right? But one of the fun or interesting things is that you can also create your own categories and classify your own things, and so that gives you more optionality now when you want to be able to figure out. Like I said before, people are building these applications and starting to try to figure out, like, are there specific roles or are there specific tasks that certain LLMs can play in my application? And if so, things like this start to become yet another building block you can use to help classify traffic and make sure it goes to the right direction. I say that because what you ultimately have the ability to do with something like this is not only classify on the inbound direction, so you can make sure that the prompts that you're getting are what you really want to be answering. And by the way, as an infrastructure company, we're oftentimes thinking about how you can optimize things, right? And so a lot of things we want to be able to do is make sure that not only you're not kind of receiving traffic that you don't want to receive. And so this is kind of a filter that can prevent your downstream or more expensive LLMs from getting hit with requests that you don't want them to get hit with. But we also can then also filter on the outbound direction. And so we can have the response actually classified so that, especially for organizations that are concerned either about reputation or just making sure that the LLMs say the things that they want them to say, there's just more tools and more capabilities to give you control in both directions, all right? And this one, I think this one's huge, actually. I call it the programmer. It's interesting that LLMs were able to speak human before they spoke computer easily, interestingly. So this one gives you the ability to control how the LLM responds. In this case, specifically, you can tell it to respond using JSON. That's one option you have. You also can tell it to actually call functions. So you can actually add capabilities to your LLM that didn't exist before, or at least your LLM app that didn't exist before. You're not actually adding capabilities to the LLM. I'll take you through a couple of examples of what that actually enables you to do. So in one case, like in JSON mode, if you ask your standard LLM, and I think I asked, this was a Llama, I think it was 13B, I might have asked this question, but who won the World Series? It'll respond and say that the Los Angeles Dodgers won the 2020 World Series. That's interesting, but maybe you want a little bit more context around it than that. And maybe you want to make sure you use that context for something different. And so one of the things you're able to do is define the schema that you want for the output. And now when you ask the question, the LLM will respond with a more properly formatted answer. And so now this is something that you could use, you could leverage to do something more with. And that's interesting, but I think what's more interesting is that expands to function calling. And so now you can not only have it answer in a format that you want, but you can actually have it answer differently than it was able to do before. And so if you go to your typical LLM and you ask it, how's the weather in Hawaii right now? It'll tell you, I don't have access to real-time weather data. I know folks have probably run into that kind of, I was trained in January of 2022 or something like that. But in this case, what you do is you define a function. You tell the LLM essentially how to choose that function. It does make the function call, and now you have the LLM understand that it needs to run this function to be able to get the answer that it needs. And in this case, it calls another data source that is able to tell it, oh, the current temperature in Hawaii is 70 degrees. And so it's able to get the information that it needs to be able to give you the response that you need about something that's real time. And so when we think about the types of things that this enables, not many people are training models from scratch, but a lot of people are considering fine-tuning versus RAG and all that kind of stuff. And this is yet another technique that folks have to add knowledge to the LLM, whereas fine-tuning is often really good for the structure. So making it respond in a format that you prefer. This one is all about making sure it has the data, the knowledge that it needs to be able to give you the response that you need. And this, I think, is a really important capability. And so this is available now. This is for the Mistral 7B model, and we're going to continue to make it available for more and more of the LLMs in our catalog. Okay? Coming to some of the things that we're learning. As I mentioned, we're running these LLMs in production. We run, I lost count now, but it's the Llama series, it's Mistral, it's Zephyr. We just released the latest Mixtral model, the 7x8B or 8x7B. That's 8x7B. That came out either yesterday or we released it yesterday or the day before. I can't even remember anymore. But yeah, that one's exciting as well. We're seeing lots of experiments. This is just a sampling of what we see as we look at kind of the mixture of things we see across the model consumption, and a lot of smaller model usage. And I think it's a lot of folks that are really trying to figure out how they can leverage these smaller models, the performance, the cost savings, and the quality that they're actually getting out of some of these smaller models. So it's very interesting to see. Another thing I encourage folks to take a look at, germane to my original title for this talk, is building RAG-based LLM applications for production. If you haven't seen this, I'd really encourage a look. It's a pretty comprehensive guide that's updated, actually, that covers quite a bit around how to build these, or our experiences in how to build these RAG apps. We've been building these for a while now, and I think it's a really solid technical read just to help understand, some of the, not only the concepts, but some of the things that we struggle with or some of the things that we learned along the way. So this is one I would definitely recommend. I don't think you'd be disappointed. And just to kind of come down the home stretch here, I'm going to talk just briefly just to kind of share with you what we are building at Anyscale. I'll also have a little quick demo to show you one of the apps that we just recently released. I don't remember even how many we're up to now. It's like maybe 4 or 5 that I know of. I don't remember how many are actually out there now. So maybe I should have tempered that statement. But nevertheless, the thing that I've been talking about primarily is Anyscale endpoints. And so it's basically open source LLMs being served and or fine-tuned via API. We're making the best open source models available for the best prices. It's very easy to get started. One of these things I want to make a challenge to folks and say, hey, go sign up before I'm finished with this slide, but I always forget to say that because it's a very quick experience. I was very pleased to see how we were able to do that. And then, yeah, like pricing-wise, it's $1 per million tokens or less. I think our lowest price is 15 cents per million for the 7 billion parameter models. Mixtral 7B is 7 by 8B. 8 by 7B is, I think, 50 cents per million tokens. And so we're really just trying to get, LLMs in the hands of as many people as possible, get people to, make these cool apps, and, leverage all the performance and cost optimizations we're able to build into our solution underneath. So that's exciting. As I mentioned, we have a private endpoint solution. So for those folks that are interested in running LLMs, but they want it on their own private data in their own clouds, this is the private option we have, and it gives folks immediate time to market and all the great kind of privacy and control that comes from being able to run these solutions in your cloud, in your environment. We have the Anyscale platform, which goes beyond LLMs. I know I've talked a lot about LLMs today, but whether you're using Stable Diffusion, whether you're using computer vision models, a lot of folks, and the reason I asked about ML practitioners is because a lot of ML practitioners have leveraged this technology, Ray, underneath, which I'll talk about on the next slide, to be able to do, some of that hardcore work that, gets the machine learning workflows done. And so the Anyscale platform is all about packaging up all those workflows, making it easier for folks to get their workflows done, while also packaging in the infrastructure and ecosystem integrations. So that's one thing that we specialize in, making sure that we get the latest and greatest capabilities incorporated, the latest and greatest optimizations incorporated. A lot of what we do under the covers is related to the GPU optimizations we can offer. It's making sure we pack as much work as possible into each individual GPU so we don't have underutilization issues. That's something we hear our organizations we work with talk about. We leverage multiple GPUs to be able to distribute the workload and make sure we get things done as efficiently as possible and get things done quickly, which also then translates into lower cost oftentimes. And yeah, we make this all available in the Anyscale platform so you get faster, more cost-effective training and serving of the models that you care about. And we do it in a way that enables you to basically compose any application that you can imagine. I think any application you can imagine, you could probably try to stump the chump on that one, but it's a very flexible system that, like I said, lots of innovators are using to build really cool stuff. And then ultimately, this is all built upon the power of the open source project. It's the Ray open source project. It's been out there for a little while. It's pretty widely used. It's one of the top workloads we hear in some of the clouds. And yeah, we're really proud of having that kind of under the hood. We continue to invest heavily in making sure that continues to stay super capable. And yeah, we're excited about our opportunities to continue to innovate there. All right, enough from me. I'm going to show you a quick demo, something that we think is pretty cool. We have a blog post that was posted about this. This is something called Documentor. It's a GitHub bot that is intended to help people improve the writing in their PRs. Let me stop talking and I'll let Max take over.
Let me introduce you to Documentor, a new GitHub bot deployed to improve the writing in your pull requests. This bot is powered by Anyscale services and Anyscale endpoints in particular. And if you want to check out its source code, click the link below to GitHub. All right. Let's say we have a new pull request that changes two text files, one README, just Markdown, and one Python file that has a docstring, but both files are kind of flawed, have grammar mistakes and spelling errors. All right, let's create this pull request. And once we do, you will see that within a second or so, Documenter will actually respond by greeting you and telling you how to use it. The main command is Documenter run. And if we paste this command into a new comment, the bot will be triggered and we will get a response soon. While this command is running, let me tell you about how Documenter actually works. So technically speaking, it is a GitHub app that needs to be installed on your GitHub repo. And once you add mention the bot, it will get triggered and send a webhook request to our backend service, which is an Anyscale service instance, which will in turn query Anyscale endpoints, in this case, a Llama 7dB large language model. And this will respond with improvements for your documentation. And the Anyscale service will then leverage the GitHub API to write back a comment on your pull request. All right, let's see how we did. And you will see that Documenter finished analyzing the PR and it commented on the README and on the test file. It has some detailed instructions, and usually it finds all the grammar and spelling mistakes. And it also gives you improvements on how to do that. Like, for instance, here the parameters for your docstring could be added. All right. So how does it work in the background? Instead of sending all the request data for the diff in your pull request to one large language model, which can be quite a lot of work, we split up the work with a array task and send the content for each file, in our case, just 2 files, but it could be much more in practice, to an individual large language model call. All right, this is done with Ray, right? And how do we know that it's actually any good? This is difficult, but the way we approach it is we first ask GPT-4 to generate some flawed sentences, like minor short sentences or some paragraphs, and then we ask Documenter to improve it, after which GPT-4 has to judge the results of that. And if both of these systems, Documenter and GPT-4, agree largely, we consider this a good result. And so far in our evaluation, we've seen that Documenter actually gives quite solid and decent results. And of course, systems like these can always be improved, but we're quite happy with what the bot can do right now. Thanks so much.
All right. Thank you, Max. All right. Well, look, that brings me to the end of my prepared comments. I'll just call your attention to a few things. One, I encourage folks to take a look at Anyscale endpoints. The website has lots of great documentation, gets you up and running very, very quickly, allows you to do whatever experiments you want. There's 1 million free tokens that we give away for free on that. But with the QR code, I'll give more tokens. So if you hit that, we'll ask a little bit more information from you, but in exchange, you'll get more free tokens as a result. And then the last thing is, please do check out our blog. One of the things that we feel pretty strongly about is just sharing what we know. At the end of the day, we're trying to bring these models to more people, and we're also trying to just share our learnings. And we have a lot of good content that we hope is helpful for folks as they embark upon their LLM application journeys. All right. Well, thanks, folks.
Let's start Q&A. Any questions for Sidney from the audience? James, how about you start? And just a reminder, if you could please stand, and when you're done, pass the mic to either myself or the next.
Hey, thanks for the demo. I'm super interested in the JSON mode. I remember trying that out with OpenAI when it first came out, and I was a little bit overwhelmed. And I was just wondering, how you see the advantage, like how you see that it's improved, and are there any particular use cases which you see people using it for that are working well?
Yeah, for us, it's super new. By the way, we released this, was it yesterday? I think it was literally yesterday. So when it comes to what we see people using it for, it's a little bit premature, but I think a lot of what we focus on is trying to, so in one dimension, we have tried to make it as easy as possible to move from OpenAI or at least incorporate our models alongside OpenAI, because I think that's what a lot of people are doing. But when it comes to the specifics of where we're better or worse, I tend to stay away from that, and I'd rather just focus on what the use cases that people end up using it for are, as opposed to kind of trying to do a bake-off, unfortunately.
Any other questions for Sidney from the audience? Sidney, what are your initial impressions of Mistral?
Mistral or Mixtral?
Ooh, good question.
Well, I could tell you, my initial impressions of Mistral is that people were very excited about it. We saw a lot of people start to use it within their applications, and so it wasn't just that we were excited. We follow kind of what organizations and our developer users are actually interested in seeing. Mixtral also generated quite a bit of interest, and it's very interesting. It's a little bit different architecture to the models, and we're not only making it available, we're learning a little bit about how it works as a result, obviously, of running it. It's a 50-something, like 56 billion parameter model, even though I think it's actually a little bit less than that or something. Maybe it's 49, can't remember anymore. But the point is, if you multiply out the number of kind of experts in there, you get a number, but the activation is much less than that. And so we're supposed to be able to see like similar performance to a larger model, but only activating a much smaller number of parameters. And so from an infrastructure perspective, that's an interesting thing because it helps us to kind of get quality without having to pay necessarily the same tax, if you will, for running a model. But yeah, we're really excited about seeing the usage and seeing how that scales and seeing what that ultimately means when it comes to, again, the types of capabilities we can bring for an affordable price.
Hey, so I feel like you're building a layer on top of these models, right? So you're kind of commoditizing them. So do you think over time, are you gonna bring the cost down further for the users? If I adopt it, I wanna know if you're planning on doing that for 1 or 2 years down the line.
Yeah, I think for us, the models are what deliver the answers, right? So we want to make sure that the best models are available because that's ultimately going to be the thing that people want to get access to. But a lot of what we're focusing on is delivering capabilities around those models to help you build better applications. Whether it's giving you capabilities to fine-tune those models so that you can get, again, the structure that you want, giving you access to things like function calling, to be able to augment the LLMs with more capabilities, and other things that we're considering to just make developers more capable of building more and more complex and innovative apps. I think that's a big part of our focus. It's not just on bringing the cost down. That's going to continue, especially as more and more accelerators become available, as these things get much more efficient. There's, I think, a lot of opportunity for optimization in how LLMs work. But yeah, we're focused both on bringing the cost down, but also about really expanding the amount of capabilities these things can have in addition to what they know and what they can reason.
Hi, I have another question regarding the performance. How stable is the performance of the token output? Yeah, and the other question regarding performance is how is it like the first token? Is it always the same time until I get the first token, or do you measure that, or yeah? These are my questions.
Yeah, one of the things we've been doing, and by the way, is this specific to a certain model or just in general?
I don't know what.
I'll say in general. We benchmark quite a few things. Some of the things we pay attention to are time to first token, inter-token latency, end-to-end delay, things of that nature. And of course, it's going to vary depending on the hardware you use, the type of model you're using, and all that kind of stuff. But I'll tell you, in general terms, what I see is we see pretty good stability, at least in our experience, for the numbers, and we continue to invest in making them lower and lower over time. And there are things you can do to optimize for like time to first token versus end-to-end total time that it takes to answer a question. I think over time, what you're going to see is more and more options become available, because I'm not sensing that. I don't personally believe that it's going to be a one-size-fits-all world. Some people are going to want the best quality, but they don't need ultimate instantaneous latency. But then there's some that are going to require the fastest possible end-to-end time because they have a very interactive application. And so I think more and more we're going to see Yes, we do collect these benchmarks, but we're going to see a wide range of requirements, I think, from the market around what they actually need when it comes to performance from their LLMs.
And are you also a user of OpenAI? So for example, when you call the API of OpenAI, then sometimes you get fast responses and sometimes it's really slow and you cannot influence that. But can you influence that?
Can we influence the performance of OpenAI?
Yeah, of your API to OpenAI. Can you influence that, or is that also?
Just to be clear, we don't leverage OpenAI behind us. So we don't serve OpenAI. We sit next to OpenAI.
Okay, yeah.
And so we're typically, and just to be clear, and the reason I'm not like us or OpenAI is because it's usually us and OpenAI. People will use OpenAI because of the quality of the models, but as you scale, the cost of these things starts to become more of a concern, and so people start to make a little bit more judicious use of it and send the questions that the open source models can answer very easily to those, and save maybe some of the more some of the more challenging questions, or the ones that really require the GPT-4 type of stuff to those models. And so we're not in dispute about like quality. It's more just what's the right LLM for your application and the use case.
Let's give Sidney a round of applause. Thank you so much, Sidney. Sidney will be around for networking. I don't know if you guys noticed, but he has some excellent swag as well. I mean, I'm talking like Frisbees and things like this. So I consider that quite elevated. So our next presenter is Dave Nielsen. Dave is the head of AI community and senior director of developer relations at MongoDB. The title of Dave's talk is Vector Search and Document in One API Call. And without further delay, let's hear from Dave Nielsen.
Great. Hi. Good evening, everyone. My name is Dave Nielsen. It's really nice to be here. My background is in, let's see if we can adjust this a little bit here. My background is actually in community, and this is actually my first talk talking about our new vector search capabilities. And so we'll see how it goes, but I'm really happy to be here and share with you what we've recently released. But the title of this talk is about the fact that with our new release, the vectors that we store, I'm just kind of jumping right to the punchline here. The vectors that we store are in with the document. So if you know anything about MongoDB, we're a document model, and we actually store it all together in one document. So it makes it very easy for you when you're storing your vectors to store the vectors and the data together in one API call. So there's the punchline, and now we'll get into the rest of the talk. So there's a little bit about me. As I lived here in Mountain View, and well, just down the road in Mountain View, and got a family, and that's what I work for. But in my work, I work in MongoDB, and as you probably know, MongoDB is a document model, which means we store our data in JSON structures, which we actually store in BSON, which is more performant, but you think of it as JSON. And so if you aren't familiar with MongoDB, just that's what you need to know. It's a document model. It's not a SQL database. And you can use SQL to access the data, but that's really not the performant way to use MongoDB. So we do store all of our data in this document model. It's very natural and flexible. If you're already using your data in your web page and you have your relationships between your data and you want to store that data, you don't have to figure out which tables to separate your data into. You can just store it all in a JSON structure. And as I like to say, in the real world, data doesn't naturally fit in rows and columns, but it does very easily fit in a document, like a JSON structure. So, and it's very easy to change. You don't have to go and fiddle with your schemas. We do allow you to apply a schema to your document. So if you do want that sort of structure laid over your data, you can use it, but it's not required. So it makes it very simple and easy and fast to use. And instead of using objects and mapping them to lots of different tables. You simply take your objects and you store them in documents. So it's a very one-to-one relationship, much easier to get started and to intuitive for a developer using JSON. Okay, so what is MongoDB Atlas? This is basically our MongoDB as a service. We call it a developer data platform because it extends beyond what you typically think of MongoDB to other data types. So we have, for example, search. We've had that for quite a while. We now have vector search, and we have graphs and streams and all sorts of stuff. So there's a lot more there than just a document. So we're trying to meet all of your needs. And you get one query API, and you can access all of that. So it's very easy to get started and extend your knowledge to beyond just the document. Okay. So there's a lot there. And now, as of this month, we now have GA for our vector search. So that's, for those of you who might think of it as a vector database, well, we don't call it a vector database because it's just part of MongoDB Atlas. So it is a search capability, but it uses it basically the same way you would use a vector database. So you should know this, but just real quick, what are vectors? It's just basically a bunch of representations of data and the related context based on a model that you apply to the data. It gives you a bunch of numbers, and that's basically how you search. Is you can't search with text, you search with numbers. So you're always taking your text and converting it to numbers, and then you search the relationships between those numbers. And so what is vector search? Basically, vector search uses these models, these machine learning models, to find results that are most similar. So this is very important if you're trying to remember a movie, for example. You don't remember the name, but you remember some characters or what it's like. And you can search based on similar words versus having to know the actual keywords that are in the title or in the description. So you're basically searching based on similarities or semantics. And it's very powerful. How does it work? Well, you take your data, you use some sort of encoder, which would be like OpenAI or one of the other models, and you turn your data into vectors and you store it in a vector store. And that's basically what the vector database is. And we call those embeddings. Okay, and in MongoDB, those vectors are actually stored right in with the document. So like I said before, when you go and change your data and you then need to change the vectors, you can write that in one API call to update it all at once. You don't have to keep two different databases in sync at the same time. So it's very convenient and it's very practical. Just real quick, I wanted to point out that, for those, again, who are a little bit new to this subject, you're going to basically use your model both to save your data into the database so that it's saved as numbers. And then when you're querying that data, when you want to find similarities, you do the same thing. You have to turn your search keywords or sentences into vectors, and then you're going to search the database with those vector values. All right, so what are the use cases? There's lots of them. I mentioned semantic search. You're trying to find something similar, but you don't know the words. You can find it. It's very powerful. A Q&A system, sort of like ChatGPT, where you ask a question and then it's going to give you back some answers. This is really powerful when you take your own documentation or maybe internal systems of data in your company, and you're trying to find some information, but you don't know exactly what you're looking for. You can quickly ask a question. My favorite one would be every year I'm like, oh gosh, it's time to update our healthcare, which I don't even know what I have. Let me go find that in my company's documentation, and hopefully it will have found it based on the semantics of what I'm searching for. Anyway, there's a lot you can do there. Image searches, all sorts of different searches. What makes vector search stand out? Well, like I said before, it's all integrated in one, so you can use the vector database along with what you're already using. In this case, it might be your document. It's one API call, and it's fully managed if you're using Atlas vector search. We do have a CLI, by the way, where when you're developing on your laptop or your own system, you can use our CLI and tell it to install vector search and Atlas search both on your laptop so you can develop locally. It's not for production, it's just for development, but that way you're not always having to go out of your system to develop. Okay, so I thought I'd show you a little bit of a demo here. Now, basically what I'm going to show you, before I do that, this is this really cool thing I just want to point out. If you're ever kind of curious, is like, vectors are lots and lots of numbers, right? But you can kind of see it. If a vector only had 3 numbers, you could plot it in a chart like this. So if I were to, for example, search for the word apple, it'll show you what words are nearby, okay? And so this is just a 3 vector value representation, but there might be hundreds or even over thousands of vectors, and each additional dimension basically gives you more accuracy. So that's essentially how those additional values help make it incredibly accurate. All right, let me just shut that down there. All right, so I've got some code that a friend of mine helped me develop, and it's just real simple. And you can go take a look at it yourself if you want. It's if you go to my GitHub repo or account at D Nielsen, and then just look for the MongoDB Atlas Vector Search one. You'll be able to pull this down, and I've got it running. Actually, I've got it loaded up into my Visual Studio here. And what I just want to show you real quick, if you want to get started yourself, the first thing you do is you're going to go to Atlas, so MongoDB.com, and our SaaS offering there is called Atlas, and you'll sign up for an account. Very simple stuff. Once you create your account, then yeah, it's really simple. So just go do that. Then obviously you want to set up your development environment. In this case, I'm using Python. And then what we do, of course, is you need a model, right? And in our particular case, you could use an open source model. You could use OpenAI. I'm using OpenAI in this example. And so what I'm going to show you here is with OpenAI, what you're going to want to do is test to make sure you have your connections set up. So here you can see I've got the modules that I need, and I'm going to just go make sure that they're running here. Pretty simple stuff. I'm not using Colab, but I'll just run this just to get past this section here. And yeah, again, not using Colab. Okay, here I've simply imported the OpenAI modules and some other modules that are required. Okay, so here what we're doing is we are loading in my environmental variables. So this is like if you are using OpenAI, you have to go to OpenAI, you need to get yourself a key, and you just load it in your environmental variables, your .env file, and here you can see we're just loading those up. It's very simple, very straightforward. This is the OpenAI API key, and so let's run that. Okay, so that loaded up successfully. Now what we're going to do is something very simple, but it's very powerful. So if I wanted to ask a question such as of ChatGPT, I might ask it, what, I had one earlier I was going to use. Let's ask you. What should I ask ChatGPT? Anybody have a quick question? Well, okay, that's probably not going to be what I want to ask it, but okay. What is a vector database? How about that? We just recently announced, so it probably doesn't know anything about us yet. So let's give that a shot. Okay, let's give that a shot. So what is a vector database? Taking a few seconds here to load up. A little bit longer than I would like it to take. Oh, there you go. Okay, a vector database is a type of database that is specifically designed to store and manage vector data. All right, brilliant. Okay, let's move on. So anyway, that's how, it's very simple. I'm not using MongoDB here, I'm just using OpenAI, all right? Now, like I said before, you need to be able to take your data and you need to be able to store it as vectors, okay? So that's what's happening here. And what we're doing is we are going to first set up using OpenAI. Hold on one second. the module, and that ran. And then here I'm going to take the word apple, and I'm going to convert it into vectors. So there we go. It ran pretty quick. And you can see down here, these are the vectors that this particular model, which is called Text Embedding ADA 02, is creating. So in this particular case, this particular model has 1,536 values as a part of the vector, okay? And so once you've done that, you want to make sure that you're always using the same model for all of your data, otherwise it's going to not be the same length in your database, okay? So that's how you create your embeddings, and then of course you'd store that into your database. You store that into MongoDB. All right. So now we've got ourselves a model and we've been able to interact with it. We can use it to convert our data into vectors. And now let's go take a look at what we're going to do with Atlas. Okay, now, before I go any further here, let me just show you that, let's see here, I don't need that. There we go. Okay, so what would you do if you went to Atlas? So first of all, again, I'm not going to bother you with like showing you how to log in and stuff, but we have projects. You would choose your project. I just have one project here, and within that project, I have one database, which is basically a cluster, and it's called Cluster Mflix, because I named it after the database that I'm actually using inside this, or I'm sorry, the collection of data that I'm using inside of this particular demo. But what I wanted to show you was that if you go here to Browse Collections, now I have already loaded this data into the database. I got this data from MongoDB. I'm using a sample set of data. So this is very easy for you to try if you want to try it yourself. I've already loaded it in just to save time, because it does take a little while. But if you go to this page and you haven't loaded any data, you will click, if you click on collections, it will say explore your data and you can load a sample data set. Okay, this is just a screenshot just to show you what it would look like. So this is very easy for you to get started. In fact, that's really why I'm here tonight, is just to show you that if you want to play around with a vector database and OpenAI, this is very easy for you to do. It's MongoDB easy, okay? That's how easy it is. All right, so what happens is it's going to load in these different collections. Now, again, collections are like tables. If you're not familiar with the document model, these are essentially like tables, but we call them collections. And you'll notice here that there's one called Sample Mflix, okay? This is just a movie database, all right? It's a collection of movies, all right? But if you take a look at it, if I open it up here, inside you'll notice that there's some different collections, and one is called Movies. Okay, it's just a bunch of movie data. But there's also one called Embedded Movies. So in here you can see that it's the same data, but at the bottom you see the vectors. Okay, and so you can see, there's a lot of them because it's like 1,500 and whatever. So, but you can see that the vectors are stored within the document. It's all in one. So when you go to update your data, you're writing it in one transaction. It's all there or it's all not there, right? You don't have to worry about, again, going back and forth between two different databases, all right? Very convenient. Okay. So that's the data. We've already loaded it in. Again, for demo purposes, all you have to do is go to this, create a new database, go to that collections tab and click load the data. And it's going to load all of that sample data, the same data you see here. And now you have a vector database to play around with. Very, very convenient. All right, what else is going to show you here? Oh yeah, okay. So let's take a look at what that looks like. Again, here, I'm going to restart this because I can't remember the last time I ran this particular notebook. Okay, so here we go, and again, load up the modules that I need. And here, again, I'm grabbing the secrets that I need in this particular case. I'm also getting the Atlas connection string and password, etc., and connecting to the database name. Okay, and I've got the API, the open API key. So now I'm pulling them all in. All right. In this particular case, I have to make sure that, let's see, it says my IP address is 104. This is something I just have to double check real quick because network access. Okay. If I don't do this, There you go, 104, okay. It won't let me in, all right? So I didn't leave it completely open to the world, so it only lets in specific IP addresses. So if you go down to network access, it will give you the ability to automatically detect what your IP address is and then open up the database to that IP address, okay. So now I'm gonna go and establish a connection. In this case, I'm using PyMongo, and so it's going to establish a connection to this particular database, and it's going to set up collection to point to that embedded movies collection that I showed you earlier, and then it's going to tell me that it's connected. All right, so we're connected to the MongoDB database. Great. Now let's run a couple queries. All right, so in this particular case, I'm just going to query the movies, and let's go ahead and run that. And it's going to output 10 movies, okay? And you can see this is very typical for JSON type database. You always output an ID because that's what you then look up to the next document, and it's very quick and easy to find relationships between collections that way. Okay, so here will be the data. All right, now let's take a look at, that's just pulled out 10 databases. Let's find one by year. Okay, that's pretty easy. All right, now, what we want to do here is we want to use OpenAI, and we want to, let's see here. We're just going to initialize and make sure we're connected. Okay, good. Again, we had to reconnect because we're in a different notebook here. And now we're going to try an embedding test. Okay, so what we're going to do here is we're going to take this particular phrase, a futuristic sci-fi movie, and we're going to turn it into an embedding. Now, why do we need to do this? Because again, if you're going to search against a vector database, you have to search with numbers. You can't search with text, right? So it's going to search vectors against vectors, and that's how it's going to determine the answer or the response, all right? So that's what we did there, is we just simply said, okay, let's take futuristic sci-fi movie and turn it into an embedding of the same length, all right? That's the technically what's happening behind the scenes. All right, and let's see here. I'm going to skip past all this stuff. I think I already showed you all this. It's just simply screen captures of what I already showed you. And now what we want to do is we want to search. All right, so, oh, I forgot one thing. Okay. So once we import the data into the vector database, it's not automatically indexed. Okay, you have to create an index. And so what we're showing here is that if you go, let's see, I'll just do this real quick. If you go back into the cluster and you go into Atlas search, now I've already created this, okay? So sorry, it's already created, but you have to go and create in Atlas search this index, okay? And in this particular case, I just simply called it index plot embedding. It's a very boring name. And I would just recommend you go look at that documentation and just grab this format out of there and put it in. And this is how you actually create the index, which tells you what kind of index it is and what the fields are you're indexing, okay? So grab that out of the documentation. At the very end, I have a link to that documentation of my slides, right? But once you've done that, now you can go ahead and search against it, okay? So let's search against it programmatically. I think I already connected this. Okay, so that was very quick. All right, so let's do an embedding search. Let's see. All right, we're all connected there. All right. So now this is going to be fun. We're going to search for something in the database. So what I don't want you to do is give me the name of a movie. Instead, I want you to describe a movie, all right? Because that's what we have is a movie database. So for example, the one that I just ran earlier was imaginary characters from outer space at war with Earthlings, okay? And it gave me some examples like Pixels. I don't know if you ever saw Pixels, or Battlefield Earth, or Falling Skies. Okay, so let's do this together. What would be an example that you would like me to search? Yes.
A Christmas movie. A Christmas movie where the guy meets the girl.
All right, so let's run that. Okay, I found 5 movies. 12 Dates of Christmas, The Perfect Holiday, Snow Globe, Scrooge? Yeah, I guess Scrooge, right? So, all right, it gave us 4 there. I don't know why it didn't give us 5, but it gave us 4. So, good, that worked. Let's do it again. Let's try another one. Anybody else want to give one? Yeah.
Royale with cheese.
Okay, that would be interesting if it was able to use that. It could. Oh, is it like that? Okay, Royale with the. That's right, that's right. Okay, so let's give that a shot. All right, well, let's see. For some reason, Monty Python, but it didn't give us the one you were Pulp Fiction, yeah. So that might be too buried in the weeds of the description.
It's
Maybe
more
it's
of
not
a
all of the
movie
all
quote.
of the quotes are not in the index there. Yeah, yeah, but see, I'll bet you that might be actually looking for like specific words, whereas this is more possibly, I don't know.
Let's try Los Angeles-based, LA-based organized crime movie set in the 90s. Or if anyone can do better than that. Going off the Royale with cheese, that is.
Let's see what it does. Gangster Squad, Strange Days, Harsh Times, Colors. Still didn't get it. So maybe we need more than 1,500 and whatever vectors. Okay, so anyway, you can see how it works. And you play around with this. Sometimes it finds it, sometimes it doesn't. Let's see. Yeah, okay, so we have some different examples here. All right, so that was basically the end of my demo. But we have to end on a good note. Let's end on one that actually works. So how about, what else do you want to try? Yeah.
An inspirational movie about the early days of a tech startup.
All right, let's see what it does. Nicotine at Tomorrowland. Interesting. Search and Destroy. It's a Wonderful Life? That is so strange. I would not have thought of that at all. What were you looking for? Any movie? Well, those are inspirational. How about we do this? Still gives a 6th Day, a Biogenesis, Space Raiders. Well, okay. Gave us some movies there I don't know. Tomorrowland is the only one I know.
How about like let's make it simpler. Inspirational movie about space. Sorry if that's not exciting, but we could take some more suggestions by all means.
I like space. From Earth to the Moon, Space Raiders, Buck Rogers in the 25th Century. I don't know this one. Koi Mila Gaia? Is it? Oh, wow, okay. And Zathura, a space adventure. Is it about space?
Yeah,
Okay.
I think Sharkon's in it.
All right. Well, this might be the new way to find new movies you haven't heard of. Okay. All right. So we can wrap it up there. I want to end with just a couple of comments. First of all, again, if you want the source code, let me go back to this page here. This is a GitHub repo, my friend Suji helped me create this code, so shout out to Suji. And here's a bunch of links. Now, the links I'm sharing here with you are the product page, the docs, the docs for the sample code. So if you want to actually download or into your own MongoDB account that sample code, you can go. There's some instructions on how to do that there. And there's a forum where you can ask questions about, if you're running into any trouble or have questions about vector search, you can go to the forum. And then here's again the link to that code. And also, we are actually running in our docs at the top of our web page. In fact, let me show you this. This is actually cool. I should definitely show you this. Okay. So right at the top here, this will show up. There we go. So if you want to ask it a question, we are actually using vector search for our own docs, and you can ask it questions, like for example, how do I connect to MongoDB with Python? And what you'll see here, it says use a Python driver, and it gives you some sample code. Okay, this is using vector search to come up with this results. It's being based on, I think it's roughly 30,000 pages of documentation, and it's using the RAG model. So, this is very similar to how like a ChatGPT environment would work. All of this code that we have here is free open source code that you can download and use yourself. And again, that can be found at github.com/mongodb/chatbot. That's what I have for you.
Okay, thanks very much, Dave. Let's give Dave a round of applause. Okay, up next we have Hakan Tekgul. He is ML Solutions Engineer at Arize. The title of Hakan's talk is Evaluating and Tracing LLM Apps. So I'm very pleased to introduce Hakan, and without further delay, let's get started.
All right. First of all, thanks everyone for coming. So today, we had some great talks on how to actually build different large language model applications with different kind of methods. But what I actually want to talk about is once you actually build an application, and this doesn't necessarily have to go into production, how do you actually evaluate and debug that application? So with that, I'm going to talk about Phoenix, our open source library, and then a little bit about Arize, which is a large language model observability platform, to kind of touch on this topic. So first, I want to touch a little bit quickly on what large language model observability is, what does it actually mean, and how do you actually kind of develop an idea of observability within your own large language model workflows. Then I'm going to basically do a deep dive on two specific types of observability for large language models, which is the large language model evals and then the traces and spans. And I'm actually going to we're actually going to do a quick workshop on this where we're actually going to use Phoenix to actually evaluate and debug a large language model application in production. So first, let's talk about large language model observability. So I'm not sure how familiar you are with traditional machine learning observability, but the general idea of that is it's basically you detect issues for the models that are in production, and you have troubleshooting workflows in order to improve those models. So for a traditional classification model, you basically detect that there's a performance drop, and then you go ahead and find out that there was a drift or something else happened in the data, so you have to retrain your model in order to maintain that performance back up and running. So that's the general idea of ML observability. For large language model observability, it's a little bit similar, but there are mainly different concepts. And if you look at the large language model observability space, we basically see the space categorized in 5 different pairs. And these 5 different pairs are evaluation, traces and spans, prompt engineering, search and retrieval, and fine-tuning. So I'm actually going to focus on the first 2 today, which is the evaluation and the traces and spans. But I want to quickly touch on a few of them real quickly. So evaluation is how do you actually evaluate a large language model that you built? How do you actually kind of measure the performance of a large language model? So I kind of want to talk about that, and we're actually going to do that today in our workshop. And the second one is the traces and spans. So how do you actually debug your large language model? So basically, like when you actually build a large language model, like using like Llama Index or LangChain, there's a significant abstraction layer. So you need to basically understand and have some visibility into like where exactly, at what point the large language model application broke and like provided hallucination or something else. So that's why we need like some sort of traces and spans in order to debug your large language models. And the third one is probably the most common one, is the prompt engineering. So like how can you actually iterate on different prompt templates? How can you do like A/B testing in production so that you can actually make sure that you have the right prompt at the right time always? And then the fourth one is search and retrieval. We talked about RAG-based apps today. So it's basically troubleshooting your search and retrieval app that's already in production. Like you looked at embedding space today. So basically either leveraging the embedding space or different evals to basically understand and troubleshoot search and retrieval. And then the last one that we do not see that often in the space, but it's fine-tuning. So it's basically understanding how to fine-tune an LLM and actually like doing some data discovery, like what data should I use to actually kind of fine-tune my LLM so that it will actually have a better performance. So these are the 5 pillars of large language model observability, but I'm actually gonna touch upon the first 2, and we're gonna do a workshop on the first 2 right now. So let's actually get started. So first, I want to talk about the large language model evaluation. So again, like the main question that a lot of people ask is, okay, I built a large language model application, but how do I actually evaluate it? Like how do I know it's good? And like the application itself can have different tasks, right? It can be answering a question based on documentation. It could be going into like specific links on the internet and trying to answer a question from there. Or it could just hallucinate, right? So you want to make sure that even for different tasks, you basically have some sort of performance metric for any large language model application out there. So when you actually talk about evaluation metrics for LLMs, like in the past year, the space has been developing so rapidly that there were very different approaches when it comes to evaluating large language models. And like when first like ChatGPT came out, like there was a lot of work doing on summarization and other stuff. So the task-based metrics was very popular at first, where, for example, for summarization, you can use like Rouge score or Burr score to basically compare the AI answer versus a human answer, right? But the main disadvantage of doing this is you always need some sort of reference human answer in order to actually use these Rouge and Burr scores, which is actually not that effective. The second one that was also very, very common is having like user-provided feedback. So like if you log on to ChatGPT, ask a question and get an answer, you can always provide a thumbs up and thumbs down. So let's say in your case, in your large language model application, if you have a similar customer-facing UX, you can actually kind of provide this thumbs up, thumbs down interface and basically get feedback from the users to basically measure the performance of your large language model. But again, like the main problem with this is also very sparse, right? Like not everyone actually uses the thumbs up and thumbs down button. Sometimes they just re-ask the question by iterating on the prompt, or they just quit the application. So like there's actually no way of knowing like when a user is frustrated, how do they actually know? Like maybe you can actually find out from the prompt or something that has been iterated, which actually comes to the first point, which is the LLM assisted evaluation. So this is actually kind of what most companies are working with right now, where they're actually literally using AI, like a powerful tool that you have, to actually evaluate basically a prompt to understand where and why your model failed. But if you look at this LLM-assisted evaluations, there's actually significant problems. Like, as you might know, like a lot of companies are developing with these LLM evaluations. Even OpenAI has their own evals. But when you actually look at the space, like, first of all, there's a lack of benchmarking in different eval libraries. And what I mean by that is, like, if you want to evaluate another large language model, like, honestly, first all you have to do is like build a prompt template, right? So like you can say like, okay, I want to evaluate this large language model. Here is the prompt, here is the response. Tell me if the large language model hallucinated or not. So in this case, it's actually a very simple template, but how do you know that this will actually work across different large language models, across different scenarios, and across different tasks? So you need to actually have some sort of benchmarking in place to make sure that your large language model actually and the large language model evals actually work in production. And another one is actually difficulty in integration. Like there are a lot of evals out there, but it's hard to actually integrate this into your existing pipeline and collect data in terms of evaluation from there, and also connect this evals to the different parts of the large language model workflow. And I will actually talk about this a little bit. And then the final one is actually confusion around metrics. So this is basically like if you actually use an eval, like sometimes like some people ask the large language model to output a score, like, okay, here is a document, here is the summary that ChatGPT created, give this a score from 1 to 5, right? And if you actually run that same code like 5 times, the ChatGPT will actually give different scores. Like it could give 3, it could give 4, it could give 3 again. So there's a certain uncertainty in terms of what's going on. So like it's important to have, like, instead of having a numerical score, having some sort of classification score to actually evaluate these LLMs. So based on these problems, we actually developed our own evals called Arize evals, which I will get to in a sec. But I think the main fundamentals of production evals can be categorized in 3 ways. So first, as I said, you need to benchmark with a golden data set so that you know that your eval is good across different large language models. The second one is the evals should be task-based. So like, and what I mean by task-based is like you should have the ability to evaluate like hallucination, user frustration, basically lag, or Q&A answers. So basically, you need to have like specific evals for each specific task so that you can actually understand where your large language model is having problems. And then finally, these evals need to run across different environments, across different orchestration tools, and they need to be as fast as possible. Because one main disadvantage of this approach for evaluation of evals is you need to actually make a call to a large language model to evaluate your prompt and responses, and that's of course expensive. And also it's very slow, there's a significant latency. So it's important to be as fast as possible as well. And we basically addressed these fundamentals and created Arize LLM evals, where you basically kind of evaluate each specific span of your large language model application. I'm going to get to basically what traces and spans are in a minute, but it's basically you evaluate each specific point in your large language model to understand if it's doing good or not. And then the second one is like we actually use the golden data sets out there. Like there are a bunch of data sets, like whether it's WikiQA or summarization data sets, to actually benchmark all of our evals across different large language models, and we actually present our results on our website so that like when you actually use our evals, you can be sure that it is going to work on like GPT-4, but it might not be great like in like Llama 7B as an example. And then, as I said, we focus on throughput. Our evals are like 10x times faster compared to the other evals out there. We have like different approaches in terms of evaluating different prompt and responses, and I can get to that in a bit, but based on these, we created our evals. So when we look at like what these evals are, right? So again, like we have this open source library that allows teams to generate these evals for different chains or spans. So like let's say the chain itself is like asking a question and then having a conversation with a chatbot, and then like you can basically give a thumbs up or thumbs down, right? So this is user feedback. But if you actually kind of go deep into the details, like there are different spans that's doing different stuff. Like for example, this is the chatbot, then the chatbot uses structured extraction, then retrieves the right context, and then does some sort of classification to basically output the final response. So in this case, you actually have to use different evals to understand like where your large language model fails. Like in this one, the user frustration eval was okay, classification eval was okay, but there was a problem with retrieval eval, right? So then you can actually understand where your large language model broke. And we're actually going to see this live today. So that's kind of what evals are. And in terms of like how they work, so when you actually like look at the different components of your large language model, at the end, like for each component, you have an input and output, right? So the input could be like the user question, and then let's say the retrieved context, and the output could be basically the answer to the user question. So basically how it works is you use the Phoenix library to evaluate this input and output. So basically, if you actually look here, and let's say we want to evaluate retrieval, right? So in your input, you have your user query and the retrieved documents and the output of the LLM. And then this is given into Phoenix library where we have an eval template specifically for the retrieval tasks. So as I said, this is a task-based eval where we're trying to evaluate the retrieval relevance of this specific span. And here's like our main eval template, like you are comparing a reference text to a question and trying to determine if the reference text contains information relevant to answering the question. Here is the data where we give the user question, the reference text, and we basically ask the large language model, compare the question above to the reference text, determine whether the reference text contains information that can answer the question. So based on this eval, the Phoenix library outputs using another large language model, whether a relevant or an irrelevant response, right? So what is this? This is a classification response. It's like a binary response. And this is more powerful than having a numerical score because it's kind of binary, and you can like, when you actually benchmark these evals across golden data sets, you can use like precision, F1 score, and recall to basically understand the performance of your eval across golden data sets. Whereas if you do this for numerical score, it's a little bit harder and uncertain. So based on these evals, we actually created evals for different tasks. So like we have retrieval eval, hallucination eval, frustration, Q&A, summarization, and code generation. And we actually have like a couple more coming, like human versus AI, citation link eval. So like again, like what we do is like we pick a specific task, then based on this task, we first develop a golden data set or actually find one online. So like here, if you go to the summarization eval, there's a bunch of different data sets out there that actually has like human labeled summaries, human written summaries, and documents. So we basically take these human written summaries and documents and then basically test our eval to see like if the eval can actually kind of understand the performance of like summarization. And then based on this, we basically target specific precision and F1 metrics to finalize our eval template. And after we pick a task, develop a golden data set, benchmark our eval template across different large language models, we basically publish our eval on our library so that other users can basically use it. So that's basically how evaluations work. It's basically a framework to evaluate and measure the performance of your large language model apps in production for any specific type of task. So next, I kind of want to touch upon like traces and spans. So like first question we asked ourselves is, how do I evaluate my large language model, right? The next question is, okay, I can evaluate it, but how do I actually debug this in production? And that's where like traces and spans come in. So like, let's say you're building a Q&A of your docs using Llama Index. And with literally like 10 to 12 lines of code, you can actually build this, right? All you need to do is like have an embeddings model, pick an LLM, and then basically create a retrieval QA chain using Llama Index, and then it will be automatically basically have a Q&A chatbot available. But this code, as I said, have a significant abstraction layer. Like if you actually look at this code, like what's running underneath is like the chatbot goes to embedding, retrieves the right context, and then calls a lot of map reduce to basically understand and answer the question towards the end. So there's a lot of stuff going on, even though if there's like 10 lines of code, right? So there needs to be some visibility on what happens behind the hood in order to debug your LLM, and that's where the traces and spans come from. So when you look at what are traces and spans and runs, so I kind of hinted at this a little bit when I was talking evaluations, but basically a chain is basically the top level of the LLM call where you have a chain and each chain has specific spans. So like this, so each trace has specific spans. So here we have trace 1, and then under trace 1 we have different spans here where like it calls a retriever, then embedding, then another chain, and then finally a large language model call again to finalize the answer. So again, like we need to have this visibility to understand, okay, like this is where my application works, or this is exactly where my application has problems, so you can easily understand what's going on within your application. And we do support different span types, retriever, embedding, tool, agent, LLM, and chain. So basically, if you have an application that's running on LangChain or Llama Index, or even OpenAI, you just need one line of code, and I'll actually show that code. And after having that one line of code, our tracer, open inference tracer, will be connected, and you will basically have these visibilities for your application in production. And we'll actually do that today, so you're actually going to see it, don't worry. But it's basically having some visibility on this. So I'm actually going to get into these details. But again, like we try to support for all common spans. We have native integration to Llama Index and LangChain with one line of code. And our goal is like to provide tools to analyze not just the end result, like not just the main user question and answer, but the steps that happens along the way, so that you can actually understand visibility around it. So, like based on what I've talked so far, like let's say you have built an LLM app, you even have an eval tested, like ready to go across a golden data set. So like now what we're gonna do in the workshop is to actually like evaluate and trace this together, right? So like here, like you have different spans, like retrieval span, then you use our open source library, which generates an eval, and then you basically visualize this in terms of spans. So we're gonna actually kind of go through this workflow together today in the notebook. So I wanna kind of, so we're gonna do a Phoenix evaluation and tracing workshop real quick. So first of all, what is Phoenix, right? So Phoenix is our open source large language model observability library. It is more for like pre-production or like close to production environments because it runs in your notebook environment. You can spin it up in a Colab notebook, which we will do today, and it helps you detect issues and find the root cause. And the use case that we're gonna do today is we're gonna deploy an LLM into production and evaluate it and debug it together. And then here I have a notebook. If you wanna follow along, you can use this link, and we have a QR code here as well. But we will also post all these materials after the workshop, so I would just say follow along using the screens. But if you want it, it's qrs.ly/6gffgzw. So that's basically what the link is. And if you actually click on this link, you will be directed to this Colab. So let me actually zoom in a little. So again, like in this Colab, we actually trace, evaluate, and analyze an application using Phoenix. So if you actually run this Colab, run just the first 2 cells, it's gonna immediately open up Phoenix for you without building anything, just for ease of use. But once you actually go down, we even have the code on how to build a Llama Index application from scratch using some documentation, and then also evaluate and trace it. So I wanna quickly go over the code, where like you actually need an OpenAI key to run it. So that's why we have the first 2 cells, which is just easier to run and see. But if you actually look at the code, you just enter your OpenAI key, and then you use Llama Index using service context and indexes to create a query engine and ask different user queries to the Llama Index chatbot that we built. Again, like just 10 to 12 lines, you can build your own Q&A chatbot. But the question is, how do you trace and evaluate it, right? So this one line of code, callback handler, which is open inference trace callback handler, enables what I have been talking about so far, which is traces and spans. So basically, by using this one line of code in your LangChain or Llama Index application, you can immediately have visibility across your components of your large language model application. So after like creating this, you can actually evaluate the application using Phoenix eval. So we have some example code here, like we have specific eval templates that we run. So we have like helper functions and everything necessary to make this as easy as possible. And like feel free to go into our docs to basically look at this. It's just docs.arize.com/Phoenix. But after basically running evaluations, you can also run the traces and spans to get this view. So let me actually do that. So if you actually run the first 2 cells, it's gonna actually create Phoenix inside the notebook first, or you can open it in a browser. So I'm actually gonna open it in a browser so that it's easier. So right now what's happening is, let's say I build a Llama Index application. By using one line of code, I enabled Phoenix, and right now Phoenix is opening up in another browser, and you will get to this view. So let me zoom in real quick. So basically, whenever you ask a question to Llama Index, LangChain, or OpenAI, it will show up here. This has a streaming capability. Any questions that you ask will actually automatically show up here. So like, let's say we ask like 4 different questions to our chatbot that uses Arize documentation, so kind of like Arize customer support, and it will automatically tell you like what is the input, what is the output, what are the evaluations, and what's the latency, what's the status, what's the token usage. So like if you actually look into this, like all of the 4 calls completed successfully. There was no errors, the status was okay. And you can see like the first input and output, like for example, how do I log a prediction using the Python SDK into Arize? And here is the output. To log a prediction using, you need to use this function, right? And then right next to it, we have evaluation. So as I said, we ran two task type evaluations here, which is a hallucination eval and a Q&A correctness eval. So if you actually look at this, like the first one says hallucination, it's factual, not hallucinated, and QA correctness is correct. So I can basically say that, okay, this specific question and answer, this specific interaction with the user actually turned out to be okay. But let's actually look at one that's like a little bit of problematic. So like the user asks, like, how do I delete a model? And then the output is to delete a model, you would need to access the model management or administration section, right? So, and if you actually look at the evaluations say, okay, this interaction is a hallucinated interaction, the large language model hallucinated here, and the QA correctness is incorrect. So the answer to this question is actually incorrect, right? So basically, you know that something is wrong at this specific interaction. But how do you actually debug this, right? So when you actually open this chain up, you actually see what's going on under the hood. So you have the retrieve that basically calls an embedding model, and then based on the retrieved text, you have the synthesize. So if I actually click on this query, I will be able to see this real life. So I have the query, how do I delete a model? This is my output, and my evaluations are here. And what Phoenix also allows you is it generates an explanation for these evals. So basically, hallucination eval tells me that this is hallucinated, and the explanation is the reference text provides information about navigating to custom metric, but it does not provide information on how to delete a model, right? So it even explains you why this specific why your large language model failed in terms of answering this question. So this is one big Q&A answer, but what we want to do actually right now is we want to debug and understand what went wrong here, right? So in order to do that, if I go into my retrieve function, I can actually see the retrieve documents here. And the retrieve documents, they're also evals run on retrieve documents for retrieval relevance. And you can see that the documentation that has been retrieved in order to answer the question is not relevant because they have a similarity score of 0 on these two documentations. So I can understand that where my application went wrong is retrieval. So it's not the large language model, it's not my embedded, it's the retriever. So what I can do is like I can actually change my chunking strategy, look at how I chunk my documents or something else to basically see what happens to my model when I ask a similar question. And if you even go to embeddings, like you have embeddings information, and then same here as well. So you can basically see anything here in Phoenix, but the important thing is to actually see these explanations as well so that you actually have an idea of what's going on, and then at the end finally figure out what's happening with your data. So that's basically how the evaluation plus traces and spans works with Phoenix. And first of all, this is again open source. With one line of code in a notebook, you can spin this up. And then this is also like, you can also see this in the notebook. As you can see, if it's easier for you, you don't have to create a browser. But this is how it usually looks. So let me quickly go back to my slides. So before I wrap it off, in Arize, we actually have a product suite for large language model observability. So we provide an open source library called Phoenix, which I just showed you, in order to iterate in this notebook and to be open source. Oh, sorry. So yeah, so we provide an open source application called Phoenix, which is basically like it runs in your notebook. It's really easy to debug what's going on. But again, it's not for scale. It's mostly for like pre-production phases. If you actually want to go into a production phase where we have like thousands of user questions coming in every second, and you want to set up monitoring, you want to basically build stuff at scale, you can use our SaaS platform, which basically has most of the stuff in additional traditional machine learning observability to basically debug your large language models. So just want to show that, but I definitely encourage everyone to use Phoenix at first. We have example notebooks and everywhere in our docs. So let me again show our docs. And we even like educate the concepts and kind of provide some education on like how everything works inside these docs too. And we have example notebooks to everything I showed, like traces, evals, and everything. So again, like today, I just want to show you and answer like 2 questions hopefully. How do I evaluate a large language model? And even if I have the ability to evaluate, how do I actually debug my large language model and understand what's going on under the hood? So thank you so much for listening. Would really appreciate if you leave us a star on GitHub. We have a Slack community. If you have any questions, you can message us in the Phoenix support channel. Here is the QR code for the community and the docs. And feel free to email me as well. But thank you for listening.
Thanks so much, Hakan. That was great. We don't have a ton of time for Q&A, but real quick question from me first, Hakan.
Yeah.
For the,
Should I turn it on?
have you,
Okay, sorry.
we can use this slide, unless you want to put the QR code back.
Yeah.
So have you used the Phoenix open source platform to check evals, traces on a workflow with Mistral or Mixtral, for that matter?
Not
Either
yet.
one? Okay.
Not yet. So our current, so we benchmarked it across GPT, Claude, Llama, and like other ones. So we are in the process of doing it for Gemini and Mistral. So hopefully we'll publish the results of our evals next week.
Yeah, hi. I'm quite impressed with our hallucination detection there. The question I have is whether there is, it is domain specific. So let's say if you start going into legal domain, or if you probably harder if you're going into a religion domain. How do you know? Will it know if it's hallucinate?
So that's a great question. So we try to benchmark our evals, like hallucination eval, across a wide range of data sets that I showed. And most of those data sets contain topics from wide different like specific areas called either legal, health, or religion. So it might work, but if you're actually working on creating your own eval, we also support that on Phoenix. You can basically create your own eval for a specific topic, and we actually walk you through the process. Like you choose a metric, you can use a golden data set if you already have one, and easily build it using Phoenix and evaluate across different large language models. But to kind of give a quick answer, like we tested our hallucination template like here, and here is like our results and everything, and the throughput. We tested across like 3 to 4 different data sets that has like a wide range of prompt and responses. So hopefully it does. I cannot say again, but you always have the option to build your own eval.
Hakan, thank you so much. I found your explanation super satisfying and thorough, so I really appreciate it. Hakan will be here for networking, so if we have any other questions for him, let's follow up then, which would more or less be right now. And to kick off networking, I guess a few final announcements. If you enjoyed yourself tonight, follow us on Twitter and LinkedIn. We post content there regularly, almost every day, in fact. Meetup.com. We have events coming up in January. You can register for those right now, so check that out. So please do. In fact, here they are. So AI for developers, if you enjoyed the content tonight, January 17th. AI for marketers, January 9th. AI for designers, January 10th. And let's start open mic announcements right here. My first announcement will be our conference, January 29th, 30th, and 31st. So if you haven't registered, go ahead and grab a GA ticket. Beyond that, we have a couple minutes. Come on up. Open mic announcements right here. If you stand here, the LinkedIn virtual audience can see you too. Arjun?
Thank you. Oh my God, my feet are sleeping. Hi everyone, my name is Arjun, like Argentina without the Tina. My quick announcement is we're looking for developers to join our team, full stack developers with especially mobile experience. Flutter experience would be great. We're building an app or scaling an app with venture funding and angel investments already raised or also about to close that focuses on helping people connect at networking events based on smart selfies. So you take a selfie, uses facial recognition, connects the two people with their permission, and then it's turning into a social network. So if you have experience in Flutter, full stack development, definitely talk. Thanks, Jackson.
Thanks, Arjun. That's an example of a perfect announcement. And here's James.
Here. Hi, I'm James. I demoed last month with my tool, which is for building React apps with AI. If anyone would like to collaborate on an open source library that could be used in multiple AI code generation projects, talk to me.
Thanks a lot, James. I think we have time for maybe 1 or 2 more announcements. And if we don't get to you this time, just come back and we'll get it next time.
Thank you. Hi, my name is Eric Myricks. I'm currently an Atlantic Fellow at the Global Brain Health Institute at UCSF, and I'm in the ideation stage of a new app that centers around brain health, wellness, using applied neuroscience and AI. So I'm very excited to just meet people here in San Fran and build relationships.
Outstanding. Thanks, Eric. These are exactly the announcements we're looking for. Anyone else want to make one last announcement before we get started? Here we go. This is the last announcement of the year, and then we network.
Hi, I'm Nick. I'm working on a startup called Valkyrie. We're making a sort of a RAG tool for data teams to be able to harness their internal data better and kind of replace data catalogs. We've got a cool demo, works pretty well. We're looking to scale it up and make it more production ready next year. And we need help because currently I'm writing all the code and that's a lot of work. So yeah, if that sounds interesting, you got some JavaScript and some time, come talk to me.
Appreciate it, Nick. Great announcement. So thank you all very much for being here. Let's enjoy some pizza. We also have cake. So maybe pick one or the other or pick the correct order and you can enjoy both. But that's entirely up to you. And LinkedIn virtual audience, thank you for being here. Happy New Year. Thanks for being here. Happy holidays.